Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your micro-OWL2 optical power meter for proper operation using a WaveSource multimode light source. Patch cables and test equipment should always be checked prior to testing to ensure accurate and reliable test results. Usually a good time to do this is at the beginning of every testing day. In this procedure, we will be using the micro-OWL optical power meter and the multimode port on the WaveSource optical light source. Now you'll see that there are two patch cables and one mating sleeve used in this procedure. Now because this is multimode, the reference cable that attaches to the WaveSource light source is wrapped around a mandrel per standards. This cable will also be used to connect the WaveSource into the link under test. This cable will be used to connect the micro-OWL into the link under test, and this mating sleeve is simply used during this procedure to check and make sure that the patch cables are working properly together. Now, one thing you need to make sure of is that when you choose your patch cables, make sure that the connector types match the testers and the link under test. Now, they don't necessarily have to match. For example, you could have SC on your light source, like you see here, but the patch panel could be LC, so in that case you would need an SC to LC cable. However, what we're going to do is assume that we're using SC patch panels. So you'll see that our patch cables are SC to SC. Now the first step to this procedure is to power on both of the testers. So we press the on button on the micro-OWL and then the power button on the WaveSource light source. You may not be able to see it very well, but you'll see that the indicator LED on the multimode port here is lit by default. And you'll see that it is red, which means that 850 nanometers is being output at this point. On the micro-OWL, you'll see that there's an operating mode screen. Okay, there's a couple different options here, simple meter and certify a link. For this particular procedure, simple meter is easier to use, so we will use simple meter. Now, since it's highlighted, we simply have to press F2 to select. Okay, now what we see on the screen here is the word under. Okay, what that means is that there's no measurable amount of light entering the photodetector. You'll see that the detector has a dust cap on it. If we remove the dust cap, we'll see that we now get a power reading. Okay, this power reading is normal. It's measuring ambient room light. So if you see a number like this with the dust cap off of the detector port like you see here, you'll see that it's just measuring ambient room light. So don't be alarmed, this is normal. Okay, what we want to do here now is check the cables. But one thing I would actually like to do first is to kind of demonstrate a feature of the micro-OWL in the WaveSource called auto mode. Okay, now auto mode simply allows the user to measure two wavelengths at one time. Okay, on the micro-OWL, this is simply done by pressing the 1 key, or A for auto. Now we have auto off, so if we have to press it again, and it says auto on, and we'll see that our wavelength indicator here is alternating between a wavelength number and the word auto. What this means is that the micro-OWL is scanning incoming signals for an auto testing signal, but is not getting one yet. Okay, obviously because it's not connected to anything. On the WaveSource, this is simply done by pressing and holding the auto button and watching this indicator LED and wait, and the minute it starts flashing, immediately remove your finger. Okay, now you will know that the WaveSource is in auto mode correctly if you see the indicator LED alternating between red and green. Okay, as we can see, it is doing that here. All right, so now both units are set into auto mode, and at this point we'll connect in our reference cable. Basically the first cable we want to check today. So we click that into the multimode port on the WaveSource, and then the detector port on the micro-OWL here. All right, so now what we want to do is give the give the power meter a little bit of time to acquire the auto testing signal from the wave source. You'll see that two wavelengths are appearing here, 850 and 1300. To the right here, you'll see that there are two power readings. Okay, these are the power readings coming in from the two wavelengths from the wave source. Now our target values are minus 20 dBm, simply because that's where the light source is calibrated at. So we know that we're pretty close here. We see minus 20.32 for 850 and minus 20.05 for 1300. Now this value could be a little higher, a little lower than minus 20, but it should be close. In this case it is. One thing you want to make sure of is that you're not exceeding minus 21 dBm, because if that happens, then something else might be wrong with the reference cable and it shouldn't be used. But for now, we know that this is actually a good reading, and for the purpose of checking the second cable, we would just temporarily zero out this cable just to make sure that we know that that the power meter knows what the reference value is. So in this case, we simply press the F2 button, or we can press the 0 key here, and it'll ask us to set 850 and 1300 nanometer reference. We will confirm by pressing F1. Now, again, waiting for the power meter to gather both wavelength signal, we'll see that we see two readings on the screen, and now we see 0 dB. Okay, what this means is we have successfully zeroed our power meter in simple meter. Now we want to connect this other cable in just to check it. So we disconnect from the power meter here. Notice that we will lose our auto testing signal. This is normal. Don't be alarmed. Again, we're measuring ambient room light. So we put the mating sleeve on the end of the reference cable. We take the second cable that we're testing, we plug that into the other side of the mating sleeve here, and then we plug the other end of the test cable into the micro owl. Okay, again, we want to give the power meter time to gather both signals here. Okay, and you see we have done this. We have a reading of 0.43 for 850 and 0.5. What this means is that this orange cable here and this mating sleeve are adding about a half a dB of loss into the link. Okay, now this is actually acceptable. Okay, the reason we want to check this cable first, though, is that we want to make sure that it's not introducing any too much loss into the link, because whatever loss is in this cable will be added into the measurement. However, since we're about a half a dB or less for both the cable and the adapter, we know that this cable is fine. So we know, both cables are okay to use for testing, and now we can continue on with our measurements.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL technical support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.